Hi everyone, Miss Nelson here. Today, for day 2 of our Unit 9, our objective is how does our Earth, Sun, and Moon move? Now, our Unit 9 is entirely on the Earth, Sun, and Moon. So today we're going to talk about how those three objects move in space. To start, for your do now, I want you to answer the question, in what direction does the sun rise? And in what direction does it set? To help you answer this question, I have a video of a simulation. Before we begin, I'm going to point some things out about the simulation that will help you answer this question. So first, the simulation is supposed to be near Manhattan, New York. And the sun's path will be the path that it takes in April. The reason these two things are important is that the path will be slightly different in different parts of the world, and it will be different based on the time of year. However, the direction that the sun rises and sets will always be the same. It just is different how high up the sun moves based off of where it is and what time of year. In this simulation, it's also important to note that we are pretending that the camera is facing due south, so east is on our left and west is on our right. All right, now let's watch the simulation to see how the sun moves. All right, as you can see, the sun appears to rise in the east and set in the west. But does the sun actually move? No, the earth spins, so the sun appears to move. It's just like if you spin around in your room, all the objects in the background will appear to move, but really they're not moving. You are. So our first motion, which is a motion that both the Earth, Sun, and Moon move, the way that they move is rotation. Rotation is the turning or spinning of an object on its axis. Another word for rotation is spin. An axis, you can imagine it as an imaginary line that goes through our planet, that the Earth spins around, in the same way that a bead spins around a piece of string. But in this case, an axis is just an imaginary line that goes through our Earth. The next question we might ask ourselves is, how long does it take Earth to rotate or spin around its axis? To answer that question, we are going to need to look on our Earth Science Reference Table, page 15. So go ahead, pause this video, take out your Earth Science Reference Table, and flip to page 15. You can restart the video when you have it in front of you. On page 15, we are going to focus particularly on this section down below, where it says solar system data. So, looking at that table, let's remind ourselves of the question, how long does it take the Earth to rotate? The first part of the table that we're going to look at is this left-hand column that has all the celestial objects. Celestial just means space, so these are the objects in space in our solar system. We have our sun, all the planets, and then finally they've included Earth's moon. But for this question, we are just focusing on our planet, Earth. And we want to know how long it takes Earth to rotate. So now we have to look at the other columns to see which column will give us the information that we need. The first is the mean distance from the sun. But the distance from the sun is not going to help us answer how long it takes Earth to rotate. Next is the period of revolution. And finally, the next column is the period of rotation at equator. That keyword rotation matches with our question keyword rotate. So we know that this is the correct column. Now, if we follow our row down and our row to the right and our column down, we will see that the answer to our question is 23 hours, 56 minutes, and 4 seconds. So, how long does it take Earth to rotate? 23 hours, 56 minutes, and 4 seconds. That is really close to 24 hours. And 24 hours is 1 day. So how long does it take Earth to rotate? About 1 day. The other motion that we're going to be talking about today is revolution. Revolution is a motion of an object around a point in space. Or another word for revolution is orbit. So not only does our Earth spin, but it moves around the sun. And our moon moves, not only does it spin, but it moves around our Earth. How long does it take Earth to revolve or orbit around the sun? To answer this question again, we need to look at our solar system data and our Earth science reference table. And our question is again, how long does it take the Earth to revolve around the sun? To answer this question, again, we're going to start in that left-hand column and find Earth. But this time, we're going to look for the period of revolution. If we follow the columns and the rows across and down, we will get that the period of revolution for the Earth is 365.26 days. So, how long does it take Earth to revolve or orbit around the sun? 365.26 days. That is about 1 year. In fact, this is how we measure a year, is how long it takes us to go around the sun once. But you might think, what about that 0.26 days? We don't usually, our year doesn't include 0.26 days. Well, let's think. Every 4 years, we have 366 days. So normally we have 365 days. That's the number of days we had for 2017, 2018, and 2019. But in 2020, we have 366 days. We call that a leap year. Basically, 2020 has 1 extra day. If we divide that 1 extra day among the 4 years, it would be 0.25 days per year. That's how we account for that little extra bit in our year. But which way do the things in our solar system spin? The Earth, the Sun, and the Moon. First, let's have a reminder of which way do the hands of the clock turn. So the hands of the clock turn in this way, and so that's why we call A clockwise and B counterclockwise. Our Earth and our Sun and our Moon all rotate and revolve counterclockwise if we look from the North Pole. So if we look from the North Pole, it will spin counterclockwise. So now we're going to look at each of the parts, the rate of rotation, the rate of revolution, and which is faster. So first, let's look at the sun. What is the sun's rate of rotation? So we need to go to our Earth Science Reference Table, find the sun, the period of rotation, And we can see that the period of rotation will be 27 days. So the sun's rate of rotation, 27 days. The sun's rate of revolution, again, we find the sun, this time the period of revolution. And if we follow it over, we see that there's just a dash. That's because the sun doesn't revolve. It doesn't move in space. So the sun does not have a rate of revolution. So which is faster? The rate of rotation, because that's the only way that the sun moves. Now let's consider the same thing but for Earth. Earth's rate of rotation, we look at our Earth science reference table, we find Earth, period of rotation is 23 hours, 56 minutes, and 4 seconds. For Earth's rate of revolution, again, we have to find Earth, go to the period of revolution, and it is 365.26 days. Which is faster? Well, the rate of rotation, remember, is about 1 day. The rate of revolution is about 1 year. So which is faster? Earth's rate of rotation. It spins faster than it moves around the sun. Lastly, let's do the same thing for the moon. So we're going to find Earth's moon, and its period of rotation is 27.3 days. The moon's rate of revolution, again, we find the moon, the period of revolution, and we see that it is once again 27.3 days. So, which is faster? Neither. They're the same number. Why do you think it would be important that the moon has the same rotation and revolution? Well, it's important because we always see the same side of the moon because the moon has the same rotation and revolution. So there are two sides of the moon. There's the near side of the moon and what we call the far side of the moon. The near side of the moon is the moon that on Earth always faces us. It doesn't matter where you are on Earth, if you look up at the moon, you will always see that side, the near side of the moon. We never get to see the far side of the moon from Earth. The only reason we have a picture of it is because we've sent a satellite to that side of the moon. So, because it takes the exact same amount of time for the moon to rotate or spin and revolve or go around Earth, we always see the same side. That face always faces the same way towards Earth. We never get to see the back side of the moon. And that's because the period of rotation and the period of the revolution of the moon is 27.3 days. They are the same. As you may know, NASA, during the Apollo 17 mission, put a flag into the surface of the moon. This is real footage of the astronauts putting that flag into the moon. As you can see in the video, they struggled a little bit at first to set it up. But the point is that that flag always points towards the Earth. It never points away because the moon's rotation and revolution are the same. All right, so now we're going to put it all together. I want you to draw how the Earth, Sun, and Moon move. So you should draw the Earth, draw the Sun, draw the Moon. It is okay if you do not draw them to scale. And I want you to draw arrows on each of the objects and arrows to show their motion. I'm going to give you 3 minutes to draw, and then we're going to discuss it as a class together. Good luck. And I'll come back in a few minutes to discuss the answer. All right, now time to check in. So, to start off my drawing, I'm going to start with the sun. The sun is at the center of the solar system. And remember, the sun rotates, meaning it spins. And specifically, it spins counterclockwise. But the sun does not move. It stays in the same place. It has no revolution. Now we're going to talk about the Earth. The Earth also spins, or it also rotates. And remember, it also rotates counterclockwise. But the Earth has another motion. It revolves. It also goes around the sun in a counterclockwise motion. So the Earth rotates counterclockwise, but it also revolves counterclockwise. And lastly, we have the moon. The moon rotates counterclockwise, and it also goes around the Earth, or it revolves around the Earth in a counterclockwise motion. This is how each of those objects move. And that is our lesson for today. I hope you learned something about how the sun, earth, and moon move. The exit ticket is to answer these 3 questions. As a reminder, send a picture of your notes and the exit ticket to Miss LaPlaca on Remind to get full credit. All right, that's lesson for today. I hope you guys are all safe and happy, and stay tuned for more lessons. Bye.